The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
This is number 10. Block A with a mass of 10 kilograms rests on an incline of 30 degrees to the horizontal. The coefficients of kinetic and static friction are both 0.2. The attached string is parallel to the incline and passes over a massless, frictionless pulley at the top. Block B with a mass of 7 kilograms is attached to a dangling end of the string. The acceleration of B is what? So, acceleration of B dealing with this is what? That is what we're trying to find. Alright, we don't know if it's going down or up. That depends on if the gravity of B being pulled down, FGB, is larger or smaller than FG sine 30, because those are the two opposing pulley forces that you start with, that you need to figure out which one is going to win, to then start moving block A and then bring in the friction concept, okay? So first we need to figure out what FGB is. So FGB is equal to mb times 9.8 meters per second squared. So that's 7 kilograms times 9.8 meters per second squared, which is equal to 68.6 newtons. Okay? So that's what FGB is. Okay? Then we need the opposing FGA. Let's go with, this is FA. So just to make things labeling easier, you can do this differently than me. I make my own ways of keeping track of the variables. Okay? So FA is what's pulling the block A down the ramp. So that is, what is that? FA is equal to 10 kilograms times 10 kilograms times 9.8 meters per second squared times sine 30. That equals to 49 newtons. So we have FA being pulled down this way, FGB pulling down that way. FGB is bigger than FA, so overall FA and FB will be moving this direction. FA will be going up the ramp and FB will be falling down. So hey, at least we know that. FAB is going down. Now, that means that friction is going, A is going to be moving this way, the velocity is going to be moving that way, so that means frictional force is going to be opposing frictional force opposes velocity, so that means it's going to be adding to FA and opposing FGB. So now we need to figure out what frictional force is. Force of friction is Fn times mu, and thankfully they gave it to us so that it's static and kinetic friction as this. So to get it moving, it's static friction, and then once it starts moving, it's kinetic friction because it already is moving. But they're the same thing, so it doesn't matter. Nice of them to make it that way in this problem. So Fn, what is Fn? Fn is Fg cosine 30, because that's how much weight block A is pushing down to the ramp. That's how much weight the ramp will be pushing into block A. So this is equal to 49.8 meters per second squared times 0.2. FF then equals to 16.974 newtons. So let's get rid of this to not confuse us. Okay, so now we have FA, FGB, and FF. FF and FA are going this way. FB is going this way. So we need to figure out. We need to subtract. FGB is going to be the biggest one. So let's make that the beginning. The net. We're looking for net force. Fnet. Fnet is equal to FGB minus FA minus FF. We have this force, and these are opposing it. So that means we have 68.6 newtons minus 49 newtons minus 16.974 newtons. And that equals to 2.626 newtons is the Fnet. Okay? Now we know the overall force acting on this entire system. So, but we need to find the acceleration of B. So how do we do that? We take this overall net force, and then because that is equal to MA plus MB all times the acceleration of the system. We take the overall mass, and so then that means we have to divide MA plus MB, okay, to get acceleration. So that means acceleration of B, and this acceleration is of B and of A. They're tied together. They have to accelerate at the same rate. So I don't really need this, but anyways, A is going to be 0.15 meters per second squared, because this is going to be 17 kilograms, and that will end up being that. And that is the correct answer.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.